notebook.
I looked at her and I was like Kylie won.
I just guessed, so.
I guess too.
I sat here and stared at it for a good 20 minutes.
Did anyone guess it right?
I don't know. Let's take a look. I'm gonna put this into Paint, and we're gonna do this one out big. All right.
I was between 1 and 5, and I went with 1.
Control V. All right, cool. Let's take a look at what's going on here because I don't know if I'm agreeing with the answer here right now. I could be like.
I'm not either.
Dang it.
All right, let's share this. All right, are you guys in Paint? You guys are in Paint with me right now, right?
Mm-hmm.
Yeah.
Let's go. Let's do this reaction. Let's do the oxidized over here, and we'll do the reduced on the other side. So, the oxidized reaction for this thing, and I'm still on mouse move, so I'm gonna hit the Paint right for doing this. I'm gonna say Br minus yields Br2. Okay, and for the oxidized one, we could clearly see it's the other one. So it's MnO4 minus going into Mn2 plus. So I'm going to do the oxidized side first because it's easy. So the first step is make sure the elements are a balance other than oxygen. In this case, we would just put 2Br minus yields Br2. Everybody good with that? And then we got to balance the other part of this, which is the electrons, because we don't have oxygens and we don't have hydrogens, but we have that. So I have to go this and go Br2. Oh, that's a horrible R. Shame on me. Looks like a Bn. We don't want that. Oh, wrong thing. Hold on a second. I got the wrong eraser. Okay, there we go. And this is Br2 plus 2E. Everybody got that parts? Yes?
No.
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 I forgot how to do that.
I did Br minus yields Br2 plus like an electron.
Well, you have to have two of them. You have to have balanced elements on both sides, right?
I didn't know that.
Oh.
Because the example that we did, I don't think we had to do that.
Yeah, you gotta, that's rule number one. You have to have the same amount of elements on both sides. So now we're gonna do this guy over here, right? This is permanganate ions here. So we have the same amount of permanganate ions. We don't do that. Now we have to balance the oxygens. So it's MnO4 minus yields Mn2 plus what?
2H2O. 4H2O?
4H2O. You got O4. You have to balance all the O's, right? Everybody good?
Yeah.
Everybody seeing where we're going wrong? I'm not trying to like, this is like a learning experience. So it's not that big of a quiz as far as count goes, right? I know some people got lucky maybe, or they figured it out, or they really worked it.
I actually worked that part.
Okay. So the next thing is we got to balance the H's. So we got to put what? MnO4 minus plus what?
4H.
4H2
Whoa, 8H plus.
Oh,
Right?
Okay.
yeah.
And this is
that's what I
Mn2
did.
plus 4H2O, right? Are we good?
Yeah.
Then how do we balance those H's?
With 5 electrons.
Okay, so we got to go MnO4 minus plus, right?
So then it will be 2.
H plus 5, E minus yields, right? In this case, Mn2, 2 plus, I keep putting the 2 on your side. It looks right to me for some reason.
Wait, why'd you do 5E minus?
So you have 6 electrons, right? So it's 6 minuses plus 8 plus gives you 2 on this side, 2 on that side. They have to be equal in charge on both sides, right?
Wait, where do you have 6 electrons?
Well, 1 here. Well, 6 negative charges. 1 here,
Oh.
5 here, so it's total of -6. And you have 8 there, so it's balanced, right?
Mm.
Then, what are we going to do? We have to do what?
Multiply.
Yep. So this guy right here, we put parentheses here. He will be multiplied by, to get rid of the electrons, 5. And he would have to be multiplied by 2. And at that point, you can answer your question. But for our own edification, because that's what it's all about, we are going to put this together for fun, right? So this guy, 5 times this would be 10 Br minus yields 10, oh, sorry, wrong number. Let's make this 5 Br2, okay? 5BR2 plus 10E minus. And let's do the same thing with this one. This would be 2MNO4 minus plus, good God, 16H plus good God, 10E minus yields 2Mn plus 2 plus 8H2O. So let's get rid of what we don't care about. In this case, it would be, we don't want him. They cancel out. That's the whole idea. Cancel those two out, right? And if we look at this, we're kind of just bring everything else down, right? There's nothing else you can cancel out. Is there?
If I had done the BR part correct, I would have gotten it.
Hmm.
But I didn't.
Oh, I forgot the BR just then. No one stopped me. But this was complex. I mean, that's why I didn't ask a whole lot of it. I just asked one. Did anybody get it correct?
Yeah.
Yeah.
Nope.
Wait, if it's 2.
Yep.
But
And this would
that
be
was
5.
just like guessing.
Was
I
it just
worked
a
that.
guess?
Well,
No.
like I honestly just saw the MN2 and then was like, I didn't know how to do it, so I just put 2.
That's what I did.
You
yeah.
are that lucky. You're awesome. Okay. Yeah. So this was the very complex question with and you're just basically going for 2, right? That's weird. That's a really weird, hard question, but that's how you get it. How did people do the homework last night? Good, fair, middling?
I think it was okay, mostly.
Yeah, me too. I think it was.
Yeah.
I think it was easy, but it could have not actually been.
It could have been easy. Say that
That
again.
makes a lot of sense.
I don't know.
No, like that hit me deep.
Did it?
Like
Yeah.
I could have oversimplified it. That's what I'm saying.
I don't know. We'll see. We'll take a look at it. Does it make sense?
Yeah.
And I think part of it is, we'll do more of the same. Just I'm saving that to, you guys can come back to it if there's questions in the future. The idea here once again is that the problems themselves, I guess, I don't know. Let's belabor the point by looking into what we're going into next. But oh, don't look at that. Oh my God, I was talking about that. It's scary as all. I did put the video up. I'm going to put this one up so you guys can go back and take a look at it. We're doing some of these because now we're going to start sticking them together. So let's do that. Let's close that. Let's close that. All right. Let's close that. Good God. All right. Boom. So what we're going to do is we're going to probably do these problems. Okay. So I'm going to give you some of these to do. And what I'm going to do is I'm going to start a couple of these with you. I'm going to do a basic solution one. Okay. Basic solution is just a little different. I think I'll do one of these. You tell me which one I should do. I'll do it. And then we'll do one that says basic solution. Okay. And then I'm going to do one of these in here. Basically, it's the combination. It's like the one we just did. So those are a little harder. So anybody have a preference to which one I want to do out of 21? Fine. Alexis, you choose. Which letter should we do? Pick an
Yes.
acidic one. Let's start with acidic.
Oh, okay.
And then we'll do a basic one.
A.
Oh, she said, oh, good. She wants to take, let's do A. We should all start with what we know. So I'm going to clip this thing and I'm going to put it, my advice is to follow what I'm doing. Okay. And it should be, how would you say, slightly unenjoyable. Let's go file, new, control.
Is this 420? What is this?
It's going to be, yeah, it's 420. What? Say what? Wait, hold on a second. Wait, I'll tell you. Back here.
423.
It's 423, so it's 2021. You'll have 2021 for homework. And you'll also have 2023 for homework, but we're going to work through a couple of these so you see what's going on. So some of these we will do together, okay? Okay, ready for this? So you guys ready for this? This will be interesting.
Will this
I'm-
be homework also?
Yeah, it's homework. I'm going to start you on it, and then you finish it. Does that make sense? So I'm going to grab this guy. And remember, I put oxidation on one side, and I'm going to put reduction on this end. Okay?
So is this 21A?
Yeah. And what they tell you right now is these are half reactions, so I have to figure out which one it is. And I'm only doing that one. Does that make sense? So is this being oxidized or reduced? God, please get that right.
Oxidized.
Thank you. All right. So I'm only doing this. I'm not doing this one for this guy. It's a half reaction. Okay. So I'm doing SN 2 plus yields SN 4 plus. Okay. So the first thing, do I have the right elements? Right. So number one is the elements. Elements other than what? Oxygen and hydrogen. Are they balanced? Yes. So I put a check. Right. Number two, oxygen for what? H2O. I don't have any oxygen. Bam, that's easy, right? H's, right? 4H plus. Do I have that?
No.
No. 4, right?
Electrons.
Charge.
You
with
need
E.
2 on the right.
I just put 2 on the right, so I'm all the way down here. SN 2 plus yields SN 4 plus plus 2E minus. All right? Done. How was that? Was that exciting?
Easy.
Yes.
These should be, the first set will be really easy, I'll be honest with you, because all you're doing is half of the reaction, okay? It says acidic solution, so you're using H's. I have to use a basic one, so you see it's a little bit different. When you have this step, and when you do a basic one, so if it's basic, after you put the H's in, you neutralize the H plus with OH's. You have to do an extra step. So we're going to get into that in 1 second when we do the next one, right? So file, new. So we're done with this. Don't save that. I don't want it. Anyways, so now I'm going to go grab another one, okay? I'm going to go back. I'm going to do a new share. I'm going to go here, and here we go, redox, share. So let's grab one that looks like it's going to be hard. So who wants to pick it? A basic one.
Me.
What? What do you want?
E.
E? Okay, let's, because I'm going to grab E now, okay? Everybody good with that? So I'm going to grab E. Okay, new. So I grab this. Don't. Edit, copy. Going to go back into Paint. Boom. Boom. File. New. Control V. Nice. Share. I gotta say all this out loud, so I think it sounds like I know what I'm doing, but I got a bunch of stuff on there. Everybody can see my screen? Everybody good?
Yeah.
All right, let's try this out. So if you want, first thing we could do is determine if it's an oxidation or a reduction reaction. Anybody want to guess?
Would it be oxidation?
It would be oxidation because we're going from here to here. This is 0, right? And this is what? -2. So it has to be oxidation. Everyone see that? So I'm going to put OX here. I'm an oxidation, okay? So I'm going to go OH minus yields O2, all right? Is elements other than oxygen and hydrogen balanced? Number 1, check. There's nothing else, right? So that had to be right.
Wait,
Number
don't you need to balance the oxygens?
No, elements other
Oh.
than oxygen or hydrogen. So yes, that's fine. Number 1's taken care of. So now we're going to balance the oxygen with H2O. So we would put that, what? Somebody read it out loud. Lily, you're there. Where would I put the
What?
water? Where would I put water?
On the right side.
Okay, so I go H2O plus OH minus yields O2, right? So I got this taken care of. Check.
Wait, I thought it would be like OH yields O2 plus OH. Or no, H2O, I mean, not OH.
Well, you
Yeah.
need 2 O's on the left.
You already have 2 here. You have to have 2 on this side.
Okay, I see.
You know what I'm saying? So
Mhm.
if you look at what I'm doing here, I got 2 over here. So I'm going to draw an arrow. And I have to have 2 over here. And I don't. I only got 1. So that's why now I got 1, 2. That's how you're balancing them. Does it make sense?
Yeah.
Ish. Okay. I just want to make sure everybody sees what's going on. Anytime, just blurt out a question. Don't be scared because this is where it gets confusing. And, well, you know, I don't want you guys confused. Let's go back to my equation. Now, it says I got to balance my hydrogens. I balance them with H plus. Okay. So where would I put that? Let me ask Morgan. Morgan, where am I putting my H pluses? How many and where?
On the right side, and you would put 2,
3.
3.
Yeah, 3.
Oh wait, yeah, I see. Okay, never mind.
Everyone see? Okay. Now, we have to do, it's basic. So I'm going to put this arrow and I'm going to say basic. I have to get rid of my H pluses by adding OH minus to both sides till I get rid of it. Because it's a basic environment. So to do that, how many OHs do I put to both sides? It's very easy when you look at it like that. So I'm going to give this to, let's see, someone else. Cameron Driscoll, what would I do? Or where would I put OHs? How many?
On the right.
You're going to put them on both sides, but how many? To get rid of the agent. No,
Do you do one on each? Because it's already like balanced amount on each side.
No, I need to get rid of all my H's by themselves. So how many would I add? Does everybody see what the question is?
Yeah.
There's a game pause. See these guys right here? I need to add OH minus to that, 3 of them. And in the end, you're going to make 6H2O. Everybody see what's going on here?
Yep.
So you want to neutralize this, but you're adding this, you have to add 3 OHs to this side too as well. Everybody see what's happening?
No.
Yeah.
Here, I'm going to run through it and then you're going to see it. It's going to pop right out at you, okay? So what happens here, and this is sort of strange, I got to get this out of the way so I can do this, okay? When running in a basic reaction, you get rid of the H's, because this right now, if I was to look at this equation, you say this is an acidic environment, right? It's not. It's not acidic, it's basic. So to get rid of them, you got to go like this. H2O plus OH minus, and I'm adding more. So I'm going to add 3 OH minus to this side, yields O2 plus 3 H plus, in this case, 3 OH minus. These guys will recombine to make 3 H2O. Everybody see that? H plus 3 OHs equals H2O.
Oh, yeah.
And then this goes here. Now this would be H2O plus 4 OH minus. Everybody see that?
Yeah.
This we can easily cross out, and we could cross this out and make this a 2. So our final equation doing all this stuff would be 4 OH minus yields O2 plus 2 H2O. Except we have to balance our charge, and we haven't done it. So what would we need to do? I have to add something to one of the sides. What would I add? And I ask Carter Robinson. Where are you, Carter? What do I add at the bottom? I got to balance my charge.
I'm really confused.
Okay. So if we have 4 negative charges on this side, we have no negative charges on this side. So how would I make sure both sides of the equation has 4 negative charges?
4 on the right side.
That's it. 4E minus. That's it. This is one of those things you may have to go back and watch the video again after we get done. This may be, what am I doing on this thing? Okay. And so the test is that when you do these things, I mean, I could back it all up. We could try it again. You'll see what's going on. But this one step, because the last step right here, 4 is the electrons for charge at the end. It still comes in, but we have to do the basic part first. Okay. I'll tell you what I'm going to do. I'm going to grab another one, but I don't want to take ones you're going to be doing for homework. So what I'm going to do is I'm going to go here, go back to, I'm going to grab one from 422, a basic one. And then you could see, once again.
Do we have 422 for homework?
No, just 423, okay? So I'm going to grab one. I'm going to grab another one. Wait, no. Let's grab a hard one. I hate these easy ones. No, I'm just kidding. How about this? We're going to grab F, right? Edit, copy. Let's go into Paint. And you guys, you do this one with me. This is another practice one, okay? So, file. Wait. Okay. Boom. All right, let's try this one together, okay, people? This will be fun. Here's magnesium. This will be basic. So we have our same steps, right? What's our first step? Elements, right? Elements.
They're balanced.
Second is oxygen, and we make water, right? The next one is hydrogen, right? And we do H+. It's basic, so we have to go OHs to balance. Good. And then the last step is the electrons. These do not change, right? Electrons for charge, okay? So let's start with our first step. Is the elements fine? Right, Andrea? What is so funny? Who is distracting you right now?
My brother is doing something weird.
Is he really? Here, put him on the get him out here. I'm gonna read him the riot act. He's ruining your education.
He looks weird. We're not gonna do that. I don't want him to be embarrassed.
You're not a true sister. Most sisters will embarrass their siblings at all costs. That's rule number 1. But if I was to ask you, jumping out of this question, our elements are all balanced. So I'm going to put a check mark in here. I'm going to say check. We've done this one. Okay. So the next one, right? How do we balance the oxygens? This is Andrea. What would I do to balance oxygen?
You would have to, I don't know. I'm still really confused about this.
Wait, can I guess?
Who's that?
Ryder?
Yeah. What would you do?
Do you have to add 2 H2Os to the
Yes.
left side?
So if you have this many, if you have oxygens on one side, you got to add water to the other side. So I put down 2H2O, right? Plus Mn2 plus yields MnO2. And that is correct. That is taken care of, right? So that's a check. I was trying to do these different colors. That's a mess. Let's take this out. Boom. Okay. Does that make sense? We good? Everybody agreeing with this? Check, right? So we got 2 of them down. Now, I'm not leaving Andrea off the hook because that would be mean. She's going to stay in this game until it's done. How do you balance the hydrogens, Andrea? Where do I put the H's? There's a war going on. What is that? Who is that?
That's Ryder.
That's
wow.
me.
Okay, I like that. It's great. So I thought it was just my house. It's nice to know everybody else suffers from this. So what's going on here? How do you balance the hydrogen?
You put them on the right, 4 of them.
Yes. So I'm going to put this 2O plus Mn2 plus yields MnO2 plus how many? She said 4 H pluses. Now I'm going to grab somebody from the bullpen. Josh.
Yes.
It's basic. So how do I get rid of the H's?
No H's.
How many? Where?
On the right side?
No, this is
Left side.
both.
Both.
That's, you have to put them on both. This is the one that
Okay.
has to go on both sides because you're trying to get rid of your H's. So let's just knock it out, right? This is the one that's kind of a little different than what we've been doing. So I'm going to go MnO2 plus 4H plus 4, right? OH minus. And I'm going to put 4 on this side too, right? 2H2O plus 4OH plus Mn2 plus, right? And this is what I would do because I'm learning, and it's a nice way of thinking of it. You just grab these guys like this, take an extra step, rewrite that, make that water, okay? So let's just do that right now. So I'm gonna put this here, MnO2 plus 4H2O, right? And I'm gonna put this one here, 2H2O plus 4OH, minus plus Mn2 plus. Now I have to neutralize charge. This is -4 on this side plus 2. So how would I get rid of this? How would I make these charges match? So overall, this 2E minus on this charge, right? So I have to stick 2 electrons on this side.
Yeah.
Everyone see that to make that balanced?
Wait, the 2E minus, where'd you get that?
Oh, I should write 2E minus. I gotta.
2 minus.
I'm sorry, I screwed that up. I'm jumped my gun. So I'm gonna put a different color for this. You guys see what I'm saying? This is essentially a This is essentially a -2 on this side of this equation, and this is a 0, right?
Wait, where'd you get the -2?
It's 4 times -1 for OH,
Okay.
and then you have a 2 plus on the magnesium. So this is -4. This is +2. Everyone see that? Ever see when I get the -2? We good?
What about the H2O? And it's
No charge.
Oh, okay.
No charge on H2O.
Okay, that makes sense.
Okay. Ooh. All right. So let me remove this because it's in my way. Let's get rid of all this. All right. So let's go ahead and fix this. We're going to do our big equation now, right? And so we have to put 2 electrons on this side. So I go plus 2E minus. Is this finished, Alexis? Can I cross anything out
Yes, the H2Os.
so I can get rid of him?
Yeah.
And I'm going to make him a 2. Everybody see what I just did? That would be your last step, and then it's perfectly fine. Is that good? Ish? Yes?
Yes.
All right. Now we're going to grab one more. We're going to do a big one, and then we're going to see where we go from there. File. Save as 20_22F. In case I have to come back. Maybe I'll put them up. I don't know. Although I think you guys are writing this all down, hopefully. File, new. All right, so we're going to do a big guy. The big guys are the ones that, one of these. Let's grab one that's fun. I don't care which one. Let's grab B. You want to do B or you want to do A? Anybody have a preference?
B.
Saturday.
Look, it says B. We should B and A. There's almost a B and E because they're a little different, right? But they're kind of having some of the same elements. So I'm going to grab B here. New. Let's grab B. Whoa. Acidic environment. A. Edit. Copy. Right? So then I'm going to go back into Paint. We're going to put them in there. Right? Boom. Control V. All right. Let's break it apart. And for this one, this is oxidation on this side, OX. and we'll put the reduction on this side, RED.
Which
So-
question is this?
I just had it. What was it?
Is this 20.3?
This is 2.223b.
Okay.
All right. So let's go back. Let me share. I'm in pink. Okay, cool. All right, cool.
That's not.
So everybody with me? Everybody's on the same page? Everybody sees what I'm doing? All right. Everybody see, so who's being oxidized? Clearly, if we look at magnesium here, what's his charge? He has to be +7, and now he's gone to +2. So he would be the reduced guy. So if he's going to go here to here, he is reduced, right? So let's put him over here, okay? So I'm going to say MnO4 minus. He's going to go down to Mn2 plus, right? So looking at this gemisch over here, we have carbon, hydrogen, oxygen, hydrogen, and obviously carbon will have to be the player on this side. You got a lot going on, but he has to be somehow the guy that's having all this effect onto him. So, because hydrogens are not going to change, right? This is like one of those things. So you can see what's going on. So we're going to put this guy on this side. So we're going to have methanol, CH3OH, being changed into HCO2. I think it's formaldehyde, H, right? Let's tear this up. Okay, starting off. So we could do the same thing. I'm going to put a 1s down the side. For our first one, is our elements balanced? Heck yeah. 2, our next step is the oxygens. Okay, this one, we'll do him easy. So it's MnO4 minus, and it's going to have how many H2Os on this side to balance this?
4.
4.
That's 4 H2Os. Smart, right? How about this guy? He has an O here, he has 2 here, so he has to do what?
1 on the left.
CH3OH plus H2O yields HCO2H, right? Number 3, we're going to go for the hydrogens now, right? Let's do this side. So what do we have to do, my friends? How are
4
we
H
balancing?
plus is on the left.
Pump the
No,
brakes.
8 H plus.
There we
8.
go. All right, good. So it's MnO4 minus plus H, 8 plus yields Mn2 plus 4 H2O, right? And we'll do this side. How many do I have to do over here? I got
4
6 here.
on the right.
Yeah, I got 6 on this side. I got 2 on this side, so I have to have 4 on that side. So I'm going to go like that. CH3OH plus H2O yields HCO2H plus, you said 4H plus, right? Now, we're down to charge, okay?
You need 7 on the manganate one.
Okay, so it has to be on this side of the equation?
Yeah.
Sure?
I think.
It has a plus 2
Good.
on this side.
Yeah, and a +7 on the other side.
No, it has to be 5.
5.
Yeah,
5.
5. Jeez Louise. I don't
And-
know how to do math.
Wait,
Okay.
how are you getting the 5? I still don't get that part.
So these have to add up to the charge on the other side of the equation. Okay, so Lily, watch what's going on. So this is plus 2 on this side, plus 4 H2O. So if we look at this side, I'm going to put a different color here for doing this. This side of the equation has a plus 2 charge, right? This one right here is a plus 7 charge. You got to take that 7 and knock it down to a 2. You have to add 5 negatives. So you have to add plus 5 negatives. You have to add 5 negatives in the form of electrons to get them to match.
Wait, and the +7, is that?
That's 8. That's, you have 8. Where's my pencil top? I can't see it. Oh my God, it's so small. Okay. I have 8 H plus right here and 1 negative. Does that make sense? So I got this is plus 7 on this side of the equation.
Yeah, I was thinking it was like 4 negatives. I don't know why, because like the O4.
Oh, Yeah, this whole thing's an ion, so it's like this.
Oh, so you
Why
only
not?
look at that.
Yeah.
Okay,
Does that make sense? Is that good?
Yeah.
All right, cool. And on this side, what do we have a problem with? We have 4 H pluses here.
And nothing
So-
else. So
so it'd be
U
4
E
On
minus.
the right.
Yes. Okay, so let me go back to black. Kind of keep
Let's
this thing
get
looking
it.
good. This will be what? CH3OH. I picked a good one. Plus H2O yields HCO2H plus 4H plus 4E minus. Sweet. Now we have to balance them because we have to cross out our electrons. In order to do that, what is the lowest common factor for actually eliminating
20.
this?
20.
20.
So you have to times this side by 5, and you would times this side by 4. Good Lord. All right, let's do this one first, right? So it's, I'm gonna put this 5CH3OH plus 5H2O, right? Yields 5HCO2H plus 20H plus 20E minus. Dang. So I'm going to put the other one directly underneath of it. I'm going to put it in a different color, maybe red, right? So this one is 4 times MNN. So it would be 4 MNO4 minus plus, wow, 4 times 8 is 32. 32H plus, golly, plus 20E minus yields, wow, 4 MNN plus 2 plus, wow, H2O, 16 H2O, 16 H2O. And the reason why I put them on top of each other, it makes it easier for crossing out. So once again, I'm going to change my thing. I can start crossing things out I don't need anymore. So let's start with this one. I'm going to cross this guy out and this guy out and make it a 9. Everybody agree with me? Well, it doesn't really matter. I just did it anyways. Let's do this guy. The electrons are gone.
Wait, it makes an 11, right?
11.
Well, I'm glad you guys are paying attention. I always think that no one's ever listening, and I got to do something. No, I mean, anybody agree with me? No, and no one says anything. So yeah, you're right. It does makes it 11. So looking at that, this is an 11. Thank you for. But you know what upsets me is Alexis didn't say anything.
Sorry.
Okay, I'm over it now. All right, so I'm going to cross the. Where am I now? Where's my pencil top? Okay, here. And I cross this out, and they should go away, right?
Yes.
So if I cross this one out, this would leave me with 10 H's over on this side.
Isn't it 12?
Yes, it is 12. Just seeing if you're paying attention. This is once
See,
again.
I didn't know. I started second guessing my
No, don't
subtraction
start.
skills.
I'm not. I'm just trying to see if you guys are paying attention. Wait, this is 12. Okay. Now, so now, unfortunately, you got to kind of rewrite this, take a look at everything, and see if we have to know if you really did it right.
You find the charges,
The charges. So I'm going to grab another color. I don't know.
and
what
they
color
are
it is.
equal.
They are equal. So let's
Yeah.
write our
Yeah.
equation. It's 5CH3OH plus 4
Oh,
MnO4 minus, right? That's all that's on. Oh, plus 12H plus, right? Yields. Yields. What's it yield? 5 HCO2H plus 4 Mn plus 2 plus 11H2O. Good God, I picked a horrible problem. 11H2O. That should be 11. Okay.
What does it say after the 4?
Mn plus 2.
Okay.
Right? Now, is anybody smart out there? I'm putting pressure on Luke and I'm putting on Alexis, and I'm looking at somebody that could probably figure this out because they're really smart people that can figure out a shortcut. And if I say a shortcut by saying, suppose this was done in a basic environment, what could you do?
I got an idea.
What you got?
Yeah, so like when you have the 4H pluses, like a couple steps ago, and you add the 4E minuses, could you instead just add like 4 OHs?
No.
Oh, okay, never mind.
Now, but what you could do here is once we get here, I could do this whole equation. If I said all of a sudden it's in a basic environment, that's what I'm saying about, right? Where's my pencil top? I can't see it. This is so little. Oh, it's way up here. So what you could do, and this is really, really interesting, I can at this point in time add plus 12 OHs here, right? Plus 12 OHs here. Can I do that? I don't know if I can do that when I think about it.
Would you still have one water then? I mean, yeah, on the left.
Well, this will make 12 waters on this side. Then you have to cross out these right here, which makes one water on this side. And then you have 12 OHs on this side. But the problem is that you can't really do this because you have to balance the charge. The charge would not be balanced at that point. Right, so I guess you can't do that. So scrap that. Scrap that's a bad idea. Don't do that. Don't do that. I thought that maybe that would work, but it doesn't. Don't do that. Oh my God, that's embarrassing how bad that would work out.